Consider a weighted voting system with 6 players, P sub 1 through P sub 6. A. Find the number of sequential coalitions in this weighted voting system. B. How many sequential coalitions in this weighted voting system have P sub 6 as the first player? C. How many sequential coalitions in this weighted voting system have P sub 5 as the first player? D. How many sequential coalitions in this weighted voting system do not have P sub 1 as the first player? When we talk about weighted voting systems, we're simply talking about an arrangement. So this will be an arrangement or order of the players. And this is going to involve factorials. Now remember what a factorial is. Simply stated, if we have 3 factorial, that will be equal to 3 times 2 times 1, which is equal to 6. Well, in this case, we have 6 players, and we're going to label them P sub 1 through P sub 6. So one of the things that I want you to understand is if we have 6 players, that means that there are 6 positions in the sequential system where a player can occupy a position. For example, we could have player 1 here, player 2 here, player 3 here, player 4 would be right here, player 5 would be right here, and player 6 would be right here. Now that's going to be different than this sequential voting system. And let me just go ahead and write it down as player 2 in the first position, player 1 in the second position, and then the other positions remain the same. And these are unique. They will not be the exact same thing. So when we talk about finding the number of sequential coalitions, we're simply going to use n factorial, where n is the number of players. And then we're going to use the fact that if we lock a player into a certain position, that position can only have 1 person there, but the other 5 positions will be subject to any one of the 5 remaining players. So let's consider part A. Find the number of sequential coalitions in the weighted voting system. Now remember, we said that n is equal to 6, therefore the number of players will simply be 6 factorial. And then we go ahead and calculate that, and that's 6 times 5 times 4 times 3 times 2 times 1, which will be equal to 720. Your calculator, if it is a good scientific calculator, should have a factorial button on it somewhere. Different calculators have them in different places, so you may have to read your owner's manual in order to understand exactly how to use that. Now let's look at part B. Part B states how many sequential coalitions in this weighted voting system have P sub 6 as the first player. Now what I want to do is I'm going to go ahead and write down the 6 slots that we've been using, and we're going to put P sub 6 here. This one is locked in place. However, these remaining positions can be occupied by one of 5 people. But once you place somebody in a position here, you then have 4 left. So we can put 5 choices here, 4 choices here, 3 choices here, 2 choices here, and only 1 choice there. And if we multiply these values out, 5 times 4 times 3 times 2 times 1, that will be equal to 120. Now, one of the things I want you to notice is this right here represents 5 factorial. And if we look at part C, which says, how many sequential coalitions in this weighted voting system have P sub 5 as the last player? The answer is going to be the same. Because if I continue along the same logic, and I have my 5 positions where I'm going to place my players, my 6 positions where I'm going to place my players, and then in this part C, you'll see that P sub 5 is the last player. That's locked in place also. However, I now have my choice of 5 remaining players to put here, but once I put somebody in this position, I only have 4 left to choose from. Once I put somebody in that position, I have 3 left to choose from. Once I put somebody in that position, I'll have 2 left to choose from. Once I put somebody in that position, I will have 1 left to choose from, which when I multiply this out, I'm going to end up with 120 once again. Now remember, you're only multiplying the digits here. Okay? The P sub 6 and the P sub 5 in part B and part C, respectively, do not count in being multiplied out. So you'll notice that this is also, this last part, going to be the equivalent of 5 factorial. Now, let's discuss part D. And wait, before we go to part D, let's examine both of those real quick. Because this right here means that if n sub 1 represents the number of coalitions or sequential coalitions, then n minus 1 factorial will represent the number of sequential coalitions with one of the players already chosen for a specific spot. Okay, the last part is part D, which has scrolled off the screen, so I'm going to scroll back up to show you. Part D says, how many sequential coalitions in this weighted voting system do not have P sub 1 as the first player? When we look at that, that means that we want to discuss P sub 1 being anywhere but the first position. Well, that means that we're going to compare the fact that there are 720 sequential coalitions and if P sub 1 is not in the first place, or I should say first position, that will be equivalent to the total number of coalitions indicated as n factorial minus the number of sequential coalitions with P sub 1 in the first position. Now when I say in the first position, what I mean is just like we did in part B and part C. Here in part B, P sub 6 was locked in the first place. Well, what we're going to do is we're going to consider all the sequential coalitions where P sub 1 is locked in first place. And then we're going to subtract that from the total number of coalitions, which will leave us with the total number of coalitions where P sub 1 is not in the first place. And one way to look at that in terms of formulas would be the fact that it's going to be n factorial minus n minus 1 factorial. Well, since n is 6 in this situation, n equals 6, that means that n minus 1 will be equal to 5. So the answer to the problem is going to be 6 factorial minus 5 factorial. And we already know what 6 factorial is. In this case, it's 720. And we know what 5 factorial is, and that's 120. So we simply have 720 minus 120, which is going to be equal to 600. So there are 600 sequential coalitions where p sub 1 is not in the first position. Now, your calculator should be able to do this, where you could simply type in 6, the exclamation mark, the subtraction sign, then the number 5, then the exclamation mark, and hit equals, and it should give you 600 automatically.